This is the final section in this unit on linear functions, and as you can see, the I CAN statement for 513 is I can sketch graphs from descriptions. It's really important to be able to sketch a graph, understand a graph that's been sketched for you. Very valuable skill. So we're going to practice that a little bit. Some parts of it are pretty easy, other parts take a little while to kind of sink in and understand, but a very valuable skill because there's so much information packed in a graph, and you'll be seeing graphs in lots of different classes, not just math classes, but science classes all over the place, and it's important that you be able to understand how to interpret the things that you see and the features that you see in a graph, and then also take a description and be able to come up with a graph. So we're going to take a look at this warm-up right here. It says identify the rate of change in each description. So we've got a quick little phrase or sentence here, and we need to come up with a rate of change. We can think of rate as slope if you'd like when we're doing it graphically. That's definitely a good way to think of it. But remember, a rate is always a comparison between two different type of measurements. It's a special type of ratio. So this one says she added 4 coins per week to her collection. So if she added 4 coins per week, the rate of change is going to be 4 coins. Okay, so we're counting up how many coins, and she's doing that every week. So this is per 1 week. So I'm going to put week on the bottom here. Now again, you don't have to write it this way. You don't have to put the 1. That's totally okay if you want to. We could say that the rate is 4 coins per week. We could just write it like that. Okay, and then the next one, $2 each day. So we're going to do $2 on the top and a day on the bottom. I'm not going to bother writing the 1 on there. And then they ran 2 blocks every minute. So this would be 2 blocks every minute. Okay. So that's what that one would look like. Now you'll notice that these last two, both of them are, if we were to just write down the number that represents the rate on each one of those is 2. And that's why when we're talking about the context of a story problem, where we're given some information, if we can have a label on it, that's really going to help us in the long run interpret what's going on in this situation and make sure that we really understand. So keep that in mind. Even though these are both 2, they do represent different things. This one's measured in $2 per day, so totally different time measurement here. And here we're measuring dollars, and here we're measuring blocks. So let's take a look at some of these problems here. So it says the following graph represents the situation described. See if you can figure out why the graph looks the way that it does. So in this one, they've given us the graph. We're not going to draw the graph. We have to take this graph and we have to answer some questions about it. So we better make sure that we understand what's going on here. So again, it says Mikey started out with $14 and spent $2 every day. So like it's set up here, we want to figure out why the graph looks the way that it does, and we need to be able to answer some questions here. So Mikey started out with $14 and spent $2 every day. So it says what label should be on each axis? Well, given this information, let's think about this for just a second. You'll notice that it starts out here at 14, and 14 would correspond with how much money he started out with. He's spending $2 every day, so his dollar amount is going down even as the number of days goes up. So this is going to be days over here, and this is going to be dollars over here. So if we label the axes correctly, then we're in a much better position to be able to answer questions about this. So we're going to have dollars, that's going to be the y-axis. And we're going to have days, that's going to be the x-axis. So I'm going to have days, days be the x-axis. Okay. All right, and we've already got this labeled over here. So this might be extra writing it down over here, but that's fine. What is the starting point, and how do you know? Well, the starting point would be this point right here. The starting point would be 0, 14. That's the starting point. How do you know? Well, remember in the problem it said he started out with $14. So started with $14 at beginning. Okay, and I'm going to put day 0 on there. So on day 0, when he started this whole thing, or kept kept track of time here. On day 0 he had $14, and then it kind of slowly goes down. And it says, what is the rate of change? In other words, remember we know that rate of change is slope. What is the rate of change? Well, let's take a look here. We could figure it out by looking at the graph, but we could also just say, well, look, in the problem it said it's $2 every day. Okay, so the reason for that is, well, it said what the rate was in the setup for the problem. Or we can come over here and notice that these are both scaled with the same scale, so 1, 2, and so forth. Each box represents a 1. We could also tell this by just doing a little slope triangle right here. So he went down $2 in 1 day right here. So this would be -2 for a rise, 1 day for a run. So down $2 in 1 day. So we can either tell on the graph or tell from the description. Is the graph increasing or decreasing? Well, clearly this is going down from left to right, so this is decreasing. And a reason we could give for that is we could give a couple of reasons for that. It has a negative slope, that's going to make it go down, and we could also say that the money is going down. It's getting smaller. Okay, anything like that would be just fine as long as we can describe what's going on there. And then it says, how many days before he has no money, and how do you know? Well, let's take a look at this. There are a couple different ways that we could figure this out. So if this is how much money he has, he starts out with $14 and it just slowly goes down. He hits $12 and $10. Let's take a look right here. He has $8 on day 3. So on day 3 right here on the day axis, that's 3, and it corresponds to 8 over here on the dollar axis. So he just continues going down. He would have no money when the dollar amount is 0. So that happens on day 7. So on day 7. There's the answer. And it's because the dollar amount hits 0. That's the reason that we could give there. We could also do something kind of clever and put several pieces of the things we've been working on in the last unit together, and we could say, look, the equation here represents, or could be represented by y equals, he's losing $2 every day, and he started out with $14. So we could write a linear equation. We could even do this. We couldn't use dollars, D for dollars and D for days, but we could do something like this. The money that he has is -2 times the number of days plus 14. And then we could just say, well, we want to know when he has 0 money, so then we could solve this. So we're going to subtract 14 from both sides, and then we're going to divide by -2. If we cancel this off, we get D equals, that would be a 7. So there are several different ways that we could establish that. The easiest one is to just look at this and say, well, that's when his money runs out. The point there is 7,0. This is the day, and this is the dollar amount right here. Okay. All right, let's try one that's just a little bit more complicated, a shape that we haven't seen before. So this one says Mikey started out with $14. So was it Mikey before? Yeah, it was Mikey. So Mikey started out with $14 and he spent $2 every day for $5. So I'm going to slide this down here and we're going to take a look. Make this just a tad smaller so we can maybe see. So it starts out basically the same way, and so the shapes of the graph are the same, and then it kind of flattens off for a minute and then it goes up. Okay, so let's take a look here. He started out with $14 and spent $2 every day for 5 days. So he was losing money for 5 days, and notice what happens here on day 5. And then it says on the 9th day he started saving $1 a day. So on the 9th day he started saving money, so his money started going back up. And it says this, where is the graph decreasing? In other words, where is the graph going down? So that's going to be from day 0 to day 5. And the reason we know that is because the slope of the line, slope is negative. The rate of change is negative. It happens to be -2. He's losing $2 every day, or he's spending $2 every day. Okay, so a couple of good reasons there. Where is the graph increasing? Well, so increasing, it needs to be going up from left to right. So that's going to be from day 9 to day 16. So we'll say day 9 to day 16. And when we say where is the graph decreasing or where is it increasing, we're going to establish that by just saying on what days is it increasing or decreasing. Okay, we don't need to say what it went from. We don't need to say it went from 14 down to, what does that look like, about 4. And we don't need to say it went from 4 up to maybe 11 or something like that. We just need to say what are the days on which it's increasing or decreasing. Okay, and why do we know that? Because the slope is positive, it's going up. Okay, and let's think about what the slope would be here. Here it was going down pretty steep, going down $2 every day. Here it's going rise 1, run 1, rise 1, run. Here it's going up $1 every day. Okay, so it's positive 1 in that particular case, which matches up with what the description said. It said he was saving $1 per day. And it says, why is the graph flat between day 5 and day 9? So here's day 5 and here's day 9. It is perfectly flat. And the reason for that is not saving or spending. Okay, so we could maybe be a little bit more specific in terms of the vocabulary that we use. Here we're talking rate of change. The rate of change here is -2, and here the rate of change is +1. And we could say this. We could say the slope is 0. He's not saving or spending money. It's just plain 0. Okay? And it says, how much money did Mikey have on day 16? Well, let's follow the days out to day 16. It's right here. And then let's follow it straight up. It would hit about right there. And then let's follow that over. How much money would that represent? That would represent 11. So he would have $11 on day 16. And let's just check and see. On day 9, he had $4. And then it says he started saving $1 per day. So he went up $1, went up $1. So he would be, we're starting at 4, so this would be 5, 6, 7, 8, 9, 10. He would have saved $11 after he started saving there. And it says if we went back in time one day from when all this started, how much money would Mikey have? So we kind of started the stopwatch, or started the calendar right here on day 0. What if we backed up one day? Well, if we follow this kind of trend line, he was spending money in this pattern right here. So if we backed up, he would have had, well, let's think, if he's spending $2 a day, if we backed up one day, he would actually have $2 more. So he would actually be at $16. He would have had $16 one day before all this mess started. Okay? All right, so kind of an interesting graph right there. Let's take a look at the next page. And let's draw our own graph on this one. So we've got a description, and we've got this set up. You'll notice we've got days here and dollars there, so it's already labeled. It's already scaled and everything for us. So it says, what would the graph look like if Mikey started out with $10 and didn't spend or save for $4, spent $1 per day for 3 days, and then saved $2 per day for 4 days, and then didn't spend or save any money for the rest of the time? Now that is a whole ton of information. Okay, so let's start out with what they started out with here. So he started out with $10. So on day 0, let's start our stopwatch right here. On day 0, he started out with $10. And then it says he didn't save or spend money for 4 days. Well, if he didn't save, it's not going to go up. And if he didn't spend, it's not going to go down. So for 4 days, it's just going to stay exactly the same. It's just going to be flat. Okay? Then it says he spends $1 a day for 3 days. So he's going to spend $1 in this day, spend $1 in this day, spend $1 in this day. So there's our 3 days. He's going to go from day 4 to day 7, and he's going to go down $3. Okay? And then it says he saved $2 per day for 4 days. So he saved $2 in that day, saved $2 per day here, saved $2 per day here, and saved $2 per day here. So he had gone down to $7, but then he saved $2, saved $2, saved $2, saved $2 a day there. And then it says he didn't save or spend for the rest of the time. Well, if he didn't save or spend, it's not going to go up or down, so it's going to look like that. So kind of a weird flat and then V-shaped graph here. But notice that he ends up with more money than he started with. So if we can draw that type of graph from a description, and that's kind of a funky one. We've got 4 different scenarios going here. He didn't spend or save, didn't do anything here. Then he spent, then he saved, and you'll notice he saved a lot more and saved faster than he did when he was spending money, and then it kind of flattens off again because he wasn't doing anything. Okay, so this one says Thomas was at his home 12 blocks from school. Use the information to sketch a graph. So I am going to zoom in on this one right here. Notice that there's no dots on here and no lines, so we're going to need to be kind of careful here. It says Thomas stayed home and watched YouTube videos. So this is his distance from school along the y-axis, and this is the number of minutes that goes by on the x-axis. So his home is 12 blocks from the school. So he starts off 12 blocks away from the school, and then it says he stayed home and he just watched YouTube videos. So if he stayed home, he didn't get closer to school, he didn't get further away from school, he just stays the same distance all the time. So it's going to look like that. So a nice flat graph because his rate of change is 0. He's not moving at all. He's not getting any closer, any further away. Let's take a look at B. It says Thomas left home and walked to school at a rate of 1 block per minute. So if he walks to school, and notice this is scaled with minutes over here, so 1 minute, 2 minutes, 3 minutes, 4 minutes, and so forth, and these are blocks to school, so 1, 2, 3, 4, and so forth. So he starts off 12 blocks from school, and then he walks at a rate of 1 block per minute. So he's going to do 1 block closer to school in 1 minute, another block closer to school in another minute, and so forth. So this is basically going to go down in a stair-step pattern. So if we go down 4 blocks, now we're 8 units or 8 blocks from school, we'd need to end up right there. And so that this works out right, I'm going to go down 4 blocks. That would be another 4 minutes, so we'd be right here. And if he got 12 blocks closer to school, he would do that in 12 minutes. It's going to take him 12 minutes to walk those 12 blocks because he walks 1 block per minute. So it's going to look something like this. Okay. Now, because he's walking at this constant rate of 1 block per minute, we can make this nice slanted line at a perfect 45, and we would know that if he walked 12 blocks, it would take him 12 minutes. So they're going to cross like this. We're going to have a y-intercept right here and an x-intercept right here, or a minute intercept if you want to think of it that way. That's what it would look like. He just walks to school at a nice steady pace. On this one here, he wasn't walking at all. He wasn't moving at all. Okay? Let's take a look at the next one. I have a feeling these are going to get more complicated as we go along. Okay, it says Thomas started walking to school at a constant rate of 1 block per minute until he got to his friend's house 3 minutes later. Okay, so what he did is he started out at home, and then he did 1 block in 1 minute, another block in another minute, and another block in another minute. So take a look right here. At 3 minutes, he's 9 blocks from school. So his friend lives 9 blocks from school. Okay, so we're going to draw a little line right there. He and his friend talked for about 4 minutes. All right, so they talk for 4 minutes. Well, if they talk, that means they're not going to be moving anywhere, or at least it doesn't say they did. So for 4 minutes, so all the way over to here, whoops, all the way over to here, let's go to 7 minutes right here, okay, because that's 4 minutes. He was at 3 minutes, and 4 minutes from that would be, whoops, would be 7 minutes. So it's going to be perfectly flat to there. And then it says, and then they ran to school at a constant rate of 2 blocks per minute. So they knew they were a little bit late because they wasted time running. So they had to run to school at 2 blocks per minute. Okay, so 2 blocks in 1 minute, 2 blocks in 1 minute, 2 blocks in 1 minute. Okay, and let's see, yep. 2 blocks in 1 minute, and then 2 blocks, so we'd end up about right there. Now it's tough to graph this perfectly. You're going to have to get used to not always having grid lines, but it's going to look something like this. And what we should recognize is we can see that he was moving but not very fast. We can see right here he didn't move at all because the rate of change is 0, perfectly flat. And then we can see here he was going a little bit faster. Now if you get this to work out perfectly where it's right in between the two of those, that's totally okay. If your graph is not quite as steep and it runs into the 12, or a little steeper and it runs into the 11 or something like that, I'm okay with that, but you should try and kind of mark things out. And if we go down 2 blocks and over 1 minute, and down 2 blocks and over 1 minute, it's going to look pretty close to that, and it's going to be a pretty good graphical depiction of what goes on in our description. Okay, Thomas started walking to school at a constant rate of 1 block per minute. We've got that part figured out. 2 minutes later, he realized he forgot his homework, so he ran home at a constant rate of 2 blocks per minute. Okay, it took him 4 minutes to find his homework, and he was late, so he ran at a constant rate of 3 blocks per minute. So he was really booking it here. Okay, so let's take a look here. He starts off at home, and remember that's always going to be 12 blocks from school. He walks at a constant rate of 1 block per minute. So 1 block in 1 minute, 1 block in 1 minute. Okay, so after 2 minutes, he's only 10 blocks from school. Make that look a little bit better. Okay. He figures out that he forgot his stuff, so he runs home at a constant rate of 2 blocks per minute. So he's in a pretty big hurry. So in 1 minute, he covers those 2 blocks back to his house. Okay, so it looks like that. So again, he was kind of walking, and then he ran back home, so a little bit faster. And then it says it took him 4 minutes to find his homework. So he's rummaging around his house for 4 minutes. So let's go. This is 3 minutes because he walked to school for 2 minutes, ran home. So all the way till 7 minutes, he is just at his house. So we're going to draw this flat line right here. Okay? All right. And then once he finds it, he knows he's really late, so he's going to run to school at a rate of 3 blocks per minute. So 3 blocks in 1 minute, 3 blocks in 1 minute. Let's make that look a little bit better. Yeah, because 1 minute would be about, 1 minute would be about right here. We should be above the 8. Okay, 3 blocks in 1 minute, and then another 3 blocks in 1 minute. So it's going to look something like this. And again, I left this without the dots on there, just so you could kind of get used to it. If we superimpose some dots here, we'd probably get pretty close. But as long as we've got a general idea of what's going on and our graph depicts that, then we're in pretty good shape. So again, here's what we can see from this. He left school kind of walking. He ran home. He turned around and ran home immediately. He had to stay at home finding that homework for 4 minutes. And then you can tell, because this is a little bit steeper than that one going up and quite a bit steeper than this one going down, we can kind of tell that he was running really fast. And whether this is perfectly when he arrived at school, like this says he arrived there at about 11 minutes, or whether we get kind of close to that, as long as we've got the general idea, then we're in pretty good shape. And as long as you can draw a pretty good picture, a pretty good graph from the description, you're in great shape. If you can look at a graph and be able to answer some questions about it, that also is very good. These are very similar to what's on your assignment.